Emissivity 101, How Emissivity Can Impact Temperature Measurement with an Infrared Camera. In this example, we want to sample and report the temperature of a perfect blackbody. Thus, the emissivity of our target is 1, or in other words, the infrared radiation from the target is 100% emitted from the target surface. The actual temperature is the temperature of the target of interest. The apparent temperature is the temperature value reported by our infrared camera. Infrared cameras do not directly measure temperature. Infrared cameras measure the effect of radiated heat, perform mathematical calculations related to a calibration procedure, and then report a temperature value. When using infrared cameras to measure temperature, the objective is to make the reported apparent temperature as close as possible to the actual temperature of the target. In reality, the objects we are likely to measure are not perfect blackbodies and will have emissivity values less than 1. As such, the total radiation reaching the infrared camera could be a combination of emitted, transmitted, and reflected radiation. The temperature associated with the reflected radiation is known as the reflected apparent temperature. It is also known as T reflected or T background. The infrared camera sees the total radiation from the target of interest and cannot differentiate between the various radiation sources. The camera user must tell the instrument what makes up the total radiation, so the instrument can calculate and report an apparent temperature close to the actual temperature. Most infrared cameras have inputs for target emissivity and reflected temperature. In this example, the target of interest is opaque, meaning there is no radiation transmission through the target, and the target has an emissivity value of 0.75, or in other words, the total radiation from the target will be 75% emission and 25% reflection. If no emissivity adjustment is made to the infrared camera, how will the reflected radiation impact the camera measurement? If the temperature of the target of interest is 30 degrees C, and the source of reflection is a large cup of ice water with a temperature of 0 degrees C, and the camera emissivity setting is set to 1, the camera will report an apparent temperature lower than the actual target temperature. Think of it like pouring 25 parts of 0 degrees C cold water into 75 parts of 30 degrees C water. Similar to the cold water diluting the warm water and reducing its temperature, the colder reflected radiation will dilute the warm radiation emitted from the target surface. If the reflected energy source is a large fire with a temperature of 500 degrees C, and the camera emissivity setting is set to 1, the infrared camera will report an apparent temperature higher than the actual target temperature. The 500-degree reflected radiation will add to the 30-degree emitted radiation from the target. To make accurate temperature measurements with a calibrated infrared camera, it is important to set the camera emissivity to the target and the camera's reflected temperature to the reflection source's temperature. The next video will cover how to determine the emissivity of the target of interest for temperature measurement. Have a hot topic you want us to cover? Leave us a comment below or ask us on LinkedIn or Twitter. Make sure to subscribe for more thermal science videos like this one. And don't forget to click the bell icon to get notifications of all new videos on our channel. Thank you for watching, and see you next time on The Thermal Tutor.